Have you ever just stopped and wondered how a piece of AI goes from being, just lines of code to actually being creative? Well, today, we're going to peek inside the digital mind itself. We're going to look at the core architectures that let an AI remember, understand, and even create. So let's dive right in.
So, here it is, the big question, right? It honestly feels like magic sometimes, but how does a machine really go from just crunching numbers to showing real signs of memory, of comprehension, and even creativity? We're going to break that entire process down, one skill at a time, starting with the foundation of it all, memory.
And that brings us to our first stop. I mean, think about it. To understand a story, you have to remember the beginning when you get to the end, right? Well, for an AI that's working with any kind of sequence, like sentences or data over time, this memory is made possible by a really clever piece of architecture called a Gated Recurrent Unit, or, as you'll hear it, a GRU.
Okay, so a GRU is basically a neural network that's built to solve one huge problem, long-term memory. See, older networks, they'd often just lose track of important info from the beginning of a long sentence. GRUs fix this using this really cool system of gates that decide what's important enough to remember and what to let go of. It lets them connect the dots over really long stretches of data.
So how do GRUs pull this off? Well, they're actually a more streamlined version of another architecture you might have heard of called an LSTM. Now, while an LSTM uses 3 separate gates to manage its memory, a GRU cleverly gets the same job done with just 2, a reset gate and an update gate. This just makes them way more efficient at reaching that same goal of remembering things for the long haul.
All right, so our AI can remember things now. That's a huge first step. But, memory isn't the same as actually understanding something. The next step on this journey is to go beyond just holding on to information and start grasping its core essence. And this is exactly where autoencoders come into play.
The best way to think of an autoencoder is like an expert artist trying to draw a minimalist sketch of a really complex photograph. The goal isn't to copy every single tiny detail, right? It's to capture the most important features, the very essence of the image. It does this by learning to compress or encode data down to its most critical parts, and then trying to rebuild it or decode it back to the original.
So, the whole process kicks off with the original high-res data. This could be anything, an image with millions of pixels, a super dense document, a complex financial record, you name it. This is the full, uncompressed reality that the AI has to start with. Now this is the critical part. The autoencoder literally forces all of that complex data through a narrow bottleneck, a much smaller layer of neurons. And to get through, the network has to make some really tough choices. It has to learn to throw out all the noise and keep only the most meaningful, representative features. This little compressed version, that is the essence. And finally, it's test time. The network takes that tiny, compressed essence and tries to reconstruct the original input from scratch. And the quality of this reconstruction, well, it tells us exactly how well the autoencoder learned what was actually important. If it can create a faithful copy from just that tiny little representation, it means it successfully captured the essence of the data. Pretty cool.
So what's the point of all this? Why is it so useful? Well, take fraud detection, for instance. If you train an autoencoder on millions of legitimate credit card transactions, it gets really good at understanding what normal looks like. So when a fraudulent transaction comes along, it just doesn't fit that learned essence. The reconstruction fails, and bam, it gets flagged as an anomaly. This same idea is used for all sorts of things, like cleaning up grainy photos or finding documents efficiently.
Okay, so let's recap. Our AI can remember, and it can understand the essence of things. Now we're ready for the giant leap, creation. This is where we enter the wild, mind-bending world of Generative Adversarial Networks, or GANs, where we have 2 AIs locked in a creative duel.
And hey, don't just take my word for it. The AI pioneer Yann LeCun literally called this concept the most interesting idea in the last 10 years in machine learning. That is a huge statement, and it just goes to show how revolutionary GANs, which were first created by Ian Goodfellow back in 2014, really are.
The secret sauce of a GAN is that it's not just one AI, it's 2, and they're working against each other. First, you have the generator. Think of this one as an art forger. Its only goal in life is to create fakes, images, text, sounds that are so unbelievably good they look real. And then you have the discriminator. It's the art detective, and its only job is to tell the difference between the real deal and the forger's fakes.
So their learning process is just this constant game of cat and mouse. The generator makes a fake, the discriminator calls it out, but when it gets caught, the discriminator's feedback basically tells the generator, hey, here's how I spotted your forgery. The generator takes that feedback, gets better, and tries again. This game goes on, with both AIs getting smarter and smarter until the fakes are so good they're basically perfect.
Now, this ability to generate such realistic data has led to some absolutely amazing breakthroughs. Everything from creating stunning new art to aging photos of missing persons to help find them. But this incredible power has a dark side, a side where the game of creation turns into a game of deception.
And this is the question that keeps AI safety researchers up at night. What happens when the exact same technology used to generate a beautiful landscape is used to generate a piece of data designed specifically to fool another AI system?
This brings us directly to the pretty scary concept of adversarial attacks. Basically, these are inputs to a machine learning model that an attacker has intentionally designed to cause that model to make a huge mistake. It is, for all intents and purposes, the weaponization of a GAN's creative power.
This is the classic and frankly kind of terrifying example. Researchers took an image that an AI confidently said, yep, that's a panda. They then added a layer of carefully crafted noise, a pattern that is completely invisible to you and me. The result? To us, it's still clearly a panda, no question. But to the AI, it's now, with very high confidence, a gibbon. No joke.
The really crucial thing to understand here is that these attacks work by exploiting the very patterns that AIs use to make sense of the world, patterns that are often totally invisible or just look like nonsense to us. And what's really concerning is that this has become a constant arms race. For every defense we build, someone develops a new attack to get around it. As of right now, there are no permanent solutions.
So where does all this leave us? We've gone on quite a journey. From a simple AI memory cell all the way to a complex system that's capable of both incredible creation and, well, sophisticated deception. It's pretty clear the road ahead is going to be complicated.
You know, if we think of this whole thing as an AI skill tree, the path is pretty clear. We started with GRUs, which unlocked that foundational skill of memory. Then autoencoders came along and gave it the ability to find the essence of data. And finally, GANs unlocked the incredible skill of creation. But that skill came with the built-in risk of deception.
And that really brings us to our final thought for today. We are entering an era where AI is no longer just a tool for analyzing the world we already have, it is fast becoming a tool for generating new worlds altogether. So the challenge for all of us becomes a pretty profound one. In a future that's going to be filled with AI-generated content, how will we as humans ever be truly certain of what is real?
So where's this from? It's all coming from the channel Learn with Praveen.